So I say that this will be our last lecture for this term, and you will be today we're gonna try to finish all the topics about the route surveying, and also I will reserve about 20 minutes for the final review, and we will also have the quiz. But I don't think I have, depending on whether I have enough time or whether you have a lot of questions, the quiz will be assigned at the, could be in the class, could be after the class. I will reserve the period for you to work with. There will be some slides I want to cover, and also there's an additional lecture I plan to cover, but I don't think that we have enough time for this term. So I uploaded the slides on Ability to Learn for your future reference. If you are interested in that topic, you can go through the slides to see how we're gonna do the earthwork for the constructions of the road and also the design of the pavement. You will also learn more about the earthwork in the highway engineering if you choose to go to the pursue the career or research in transportation engineering. Before I start the lecture, is there any other questions? I see Andrew had the questions about the quiz. Yes, we have the quiz today. That will be our last quiz. Not quite sure whether you're going to be able to distribute a quiz in the class, but I can do it after class. I will make the quiz available for several hours after class so you can work on that. Okay. If there's any other questions, I will share my screen and start our lecture today. Okay. So the quiz will be assigned online. So it's as what you did previously. It's assigned on Ability to Learn, and it's not available for now. I will make it available or make it visible for you after the class, so you can go to do the simple questions. It's the question related to the route surveying, and there will be 2 multiple choice questions. Just some simple calculations to let you familiar about the material, the slides you have learned previously. Okay. With that, I will start the lecture today. So yesterday we went through the all the rest contents about the horizontal surveying, including the compound curves, how to find out the intersections on the curve and the straight lines. All of them are very important for you to design actual road. And the rest contents that we left for the route surveying is the super elevation, the design of the vertical curves, and also there will be something related to the earthwork. But that one is not is less important, so I will just skip that and not include that topic in our final exam. For the super elevation, this one is specially designed for the road with the curve. You know that due to the horizontal centrifugal force, if you drive on the road without any elevation difference, say that you draw on the curve, say that a car is driving there, your car is driving there along this curve, and due to the centrifugal force, you will be forced to move or deviate to the outside of the curve, and this is very dangerous, especially when the speed is very high or the truck is very heavy, and in that sense, the centrifugal force will be large, and it will be very hard for the driver to control their car. Or it could it could also happen for the trains, where there will be a lot of load. So to solve that issue, usually at the curves, we will apply the super elevation. We'll say that this is a regular road. Usually the elevation of the road from the left side to the right side will be the same, but at the curved road, instead of using the same elevation for the road for the pavement, it will try to specify some elevations, the elevation difference, and this would be the left, and this would be the right. And with this indicates that if you drive a car here, the centrifugal force is force you to move to the right. If we force you to move to the right, but due to the elevation difference, it can give you the support to drag you back, and this will prevent the potential negative impact from the centrifugal force to your movement on the curved road. So that's a reason for us to introduce the super elevation. In the design of the super elevation, there will be actually some standards, and usually for the design of the super elevation, we want to find out what's the appropriate slope we want to place. Say that if this is 1, then the slope could be e divided by 100. And for the super elevation estimation, the railways and the freeways will be very different. For the railways, the value of E will be in the function of the speed and the degree of the curvature. So that is a 0.00067 v squared times degree of the curve. Here, v is the speed of the road, the speed of the vehicles on the road, and d is the degree of the curve. And this is for the railway. We can just apply this equation directly. And for the freeways, the function will be different. If we apply the English units, E plus F should be equal to V squared divided by 127 times R squared. Here F is the lateral friction factor. This is one factor related to the pavement, and R is the radius of the curve. So that's for the English units, and you can also find out the degree of the curve as the function of the elevation, the slope for the super elevation. So that would be 730,000 times E plus F divided by V squared. So so this indicates that if you know the degree of the curve, or if you know the radius of the curve, you can estimate the value of E. Or if we are provided with the value of the E about super elevation, you can also calculate the desired degree of the curve. For the international units, we have slightly different variables, the coefficients. So that will be V squared divided by 12 times R squared. And we have the dA equal to 85,660 times E plus F divided by V squared. So these two type of the equations will be applied for us to design the super elevation. We just need to know what's the speed, what's the degree of the curve for the road, and then we can find out the slope applied for the super elevation. So that's the first one about super elevation. It's straightforward. We just apply the equation to calculate the slope. And the second topic would be more complicated, or would be a little bit more important for you to design the road. We know that in the construction of the actual freeways or any other type of the road, the elevations of the ground may not be flat. There might be some difference in the elevations. So in that sense, we can either cut the road to make the elevation the same along the whole freeways or the whole rail tracks, or we can design the road with different elevations. And the first method definitely will need a very high budget, but it has some benefit. It can simplify your design work. But for the second one, we definitely can save a lot of budget for the road construction. But still, we need to carefully design the route to make sure that the whole road is smooth. You don't want to drive on the road with an abrupt changes about the very abrupt changes about the slope. Say that this is an segment 1 and this segment 2. It's impossible for you to drive your car here with the slope 1 and then suddenly change to slope 2. They must have a way to have a transition period which will help you to connect these two segments smoothly. And this is the purpose of the vertical curve. So we are using this vertical curve to connect two straight lines with different slope to avoid any abrupt changes in the vertical distance. And this figure shows one common case applied for the design of the vertical curve. And we need to know how to find out the vertical curve A and B. So how to find out this curve? To do that, we will actually have multiple methods to do it. One of the criterion we have to make sure that for this curve, the slope at point A should be the same to the grade of the straight line before A, and the slope at point B for that curve A and B should be the same to the grade of the line B to B and the segment behind. So that's the requirement. With this requirement, we can then recall the apply the equation of the parabola to design the vertical curve. For this kind of method, we want to first say that we have a two straight line. Let me just draw it. Two straight line. The slope of the first segment is G1. The second segment is G2. And we know we want to design the vertical slope start from the position 0 and end at the position L, and X represent the horizontal distance, Y represent the elevations or the vertical distance. And the slope should have the same, the vertical curve should have the same, slope at the initial point. I say that the point is C, which is set as G1, and at the end point, say it's for example, if say this one is A. The point A and point B. At the point B, the slope of the vertical curve should be the same to G2. And then with the equation of the parabola, we can assume that the vertical curve, which would be the red line, the elevation of the red line, which would be y, is in a function of the distance, the horizontal distance x. But we want to make sure that there are several constraints. First, the second order derivative of the vertical curve a to b will be constant, which means that we don't want to make the road very complicated, and we just want to have the parabola curve to connect two straight lines. So that's the first one. And if we know the this is the definition from the parabola, and if we know that the second derivative of the curve is constant, then we can derive the first derivative, dy divided by dx would be r times x plus capital H. Here H is also in a constant. Let me just specify. R and H both are constant. Okay, and for the first order derivative of a function, it actually represents the slope of the curve at any specific point. And based on our requirement about the vertical curve, we want the slope at the initial point, at the start point, which would be x equal to 0, be g1, and we want the slope at the end point be the slope of the second line. And this indicates that if you recall the formula we derived for the first order derivative of the function, that would be r times 0 plus h. And the second one would be r times l plus h. So with that, you can derive the formula for the two coefficients. H will just be g1, and r will be g2 minus g1 divided by the length of the horizontal length of the vertical curve. And if you know this information, if you know the value of r, you know the value of h, and this is actually under the first order derivative, you can then further find out the formula, the full formula for equation, the full equation for y. That will be half r times x squared plus hx plus capital C, and C is also in the constant. So I should add another one. C is also a constant. And we know the value of R, we know the value of H. We can then also find out what's the value of C. For the C, you can actually see that if x equal to 0, y will be half r times 0 squared plus h times 0 plus c. So y is just c. And this indicates that if x equal to 0, the intercept of the vertical curve to the y-axis is c. So this represents the elevation at point 0 for the vertical curve. So we say that C is the elevation at x equal to 0. And then I can write down the full equation for y. we know the value of R is G2 minus G1 divided by L. So we have G2 minus G1 divided by 2L times X squared plus G1 X plus C. And this is what we get for the vertical curve with the equations of the parabola. It indicates that if we are provided with the slope of the two lines, the length of the horizontal length of the vertical curve, and also the initial elevation of the vertical curve, you can find out the function to show how the vertical curve should be constructed to connect these two sloping lines. And that's what we obtained for the equation of the parabola. And I see there's a question about what is where is the half hour from? I guess this is from the calculus. Let me just give you a quick derivation. So you have dy divided by dx equal to rx plus h. So this indicates that y should equal to is the derivative integral of r times x plus h. If you can recall the calculus. I don't have space here, so the rx plus h. If you recall this one, recall the calculus, the integral of rx, integral h plus a constant. The integral of rx will be half r times x squared. You can do the first order derivative to double check it, and then you have the hx and c. Okay, so that's the equation of the parabola. So as long as you are provided with, if you are provided with G1, G2, L, and C, you will be able to define the equation of the vertical curve. So this one is straightforward. It's very simple and straightforward. And now let's see one example to check how we can use the equation of the parabola to find out the vertical curve. In this example, we know G1 is 1.25%, G2 is minus 2.75%. And we also can find out the initial elevation here. The initial elevation is 288.94 meters, and the end, we also can find out the end elevation, which is 267.44 meters. And we know the length of L is 200 meters. And then with that, we can find out the vertical curve. So first of all, we know C equal to, let me see, what's the C equal to the elevation of point V. I guess they did not show. Do they show the elevation? No, No, it's not showing the I guess it's not showing the elevation here. Let me quickly check. It does not show the elevation of, no, that's sorry. This is not the elevation of the point A. We know the elevation at point V, and we know the distance from V to point A. Then we can calculate the elevation at the point A, which would be the elevation of V minus the vertical distance. The vertical distance from A to V. We know the slope. We know the horizontal distance. That is 100 meters. Then we can calculate this one. So that would be G1 times the 100 meters. So this is 100 meters. So elevation of V is 270.19. G1 is 1.25%. Times 100 meters, it gives you the elevation at point A. It's 268.94 meters. So that's the elevation of the point A. I guess this should be 268. This one can be calculated based on the elevation of V and also the slope of A to V. And once you know the value of C, and also we are provided with L, G1 and G2, we can first calculate the value of R. R is G2 minus G1 divided by L. G2 is minus 0.0275, G1 is 0.0125, divided by the total length is 200 meters. Then it gives you the value as minus 2 times 10 to the power minus 4. So this is the value of R. And then we can just apply the equation we derived in the previous page. Y equal to half R x squared plus G1x plus C. For R, it's minus 2 times 10 to the power of minus 4. So this is just half R is minus 0.0001 x squared plus G1 is 0.0125 x plus C is what we derived as 268.94 meters. So this is the vertical curve as we derived for the for these two straight roads with different slopes. And this equation can be applied for any two roads, any two slope, any two straight lines with any slopes. It could be positive, could be negative. So that's the first method. We also can apply another method by utilizing the vertical offset from the vertical curve to construct the to identify the curve to connect two straight lines. The advantage of this one is like originally on the road, you might actually know in the field before you do the construction of the road, you might observe this kind of these straight lines. This would be the original ground. And for the actual construction work, we have to know how much depth we want to dig at the specific location X, or if it's if we want to fill the original ground with some earth, we need to know how much earth we should put there to raise the elevation and to reach to the designed vertical curve. So in the actual construction work, we want to know what's the offset, and this one in this method we need to calculate the elevation difference between the original ground and the designed horizontal vertical curve at any location, which is y prime in this figure, and we want to find out a function to show the y prime. It's expressed as in the formula of the location, the horizontal location x. So to do that, assuming that at the location x, at x, the y is the elevation of the vertical curve at the location x, and the y prime is the original elevation of the ground. No, the y prime is not. It's the offset between the original ground and the vertical curve, the designed vertical curve. So we want to find out the expression for the y prime. With that, we can then apply the oh, there's another thing I want to mention. So that will be the sign of y prime. If the original ground is above the curve, the vertical curve, then y prime is a negative. If it's below, then that'll be positive. So this is just some common definitions about the sign of y prime. So in this figure, y prime would be negative. So with that, we can then find out the equation to show the original ground. So if we go to see the y minus y prime, which will raise you back to the slope of the original ground of the first segment divided by x, that should be g1. And we will then derive that y equal to x times g1 plus y prime, and you know that y prime is negative for this case because it's above, but if it's below, that will be positive. We also derive that in the equation of the parabola, we have y equal to g2 minus g1 divided by 2l times x squared plus g1 x plus capital C. And in this case, we actually assume that the initial elevation is 0 for the point A. So in that sense, C is also 0. So this is the assumption, C equal to 0. Then we can remove this part. With that, we will get the formula of y prime as g2 minus g1 divided by 2l times x squared. So that's the offset we can estimate, and this can also be simplified as half r x squared. So this is the offset, and you will observe that the maximum offset will be obtained at the point V. So at the point V, we have the maximum offset. So y prime will be the distance between V to M. So this is also at the location of x equal to half L. And with that, we can find out the y prime as G2 minus G1 divided by 2L times half L square. That is G2 minus G1 divided by 8 times L. And this is the way for you to find out the maximum offset. And also, if you want to do some further derivation, you can find out relationship between the offset at any location with respect to the maximum value. That is 4x squared divided by L squared times the distance of Vm. So this is about the offset. We can find out the offset between the original ground and the designed vertical curve. And this is another example about how the offset is calculated. You can actually find out the based on the design. From the previous example, you can find out the maximum offset, which would be Vm. That is guess that is the equation is G2 minus G1 divided by 8 times L. We know all the values, and if you do the calculation, you will eventually find out the maximum offset is 1 meters. And then for all the offset, you can get the value as 4x squared divided by L squared times Vm, and Vm can be replaced with 1.0 meters. So with that, you can then calculate the all the offset. But remember that the for the offset, what you can calculate is only applied for the this equation only applies for the first part of the second of the vertical curve from the start point to the midpoint. For the second part, you need to use the you have to use the slope of G2 to find out the difference between the second slope and the vertical curve. The equation will be the same. You just apply different slope to calculate the offset. Okay, so that's the design of the vertical curve. Basically, you need to remember the equation of the parabola to find out the formula, the function of the elevation as the vertical curve with respect to the horizontal distance. Okay, okay, I think that will be all about the vertical curve, and which is all about the lecture today. Do you have any questions about the about these materials? Okay, if no, then I will reserve the rest of the time for the review of the final exam. So let me quickly go through the so here is the some information about the final exam. The final exam is scheduled on Saturday from 9 to 13. No, not PM. 9 to 13 a.m. Sorry. 9 to 11:13 a.m. And the is scheduled on Saturday. Next Saturday. This time is reserved for our class by the university. I will also the 2.5 hours will be sufficient, but I will also want to give you an extension about 15 minutes so that you have some extra time to upload your answer sheet. Well, just in case you have any issues, because it will be hard for us to do some makeup exams for the final test. The format will be exactly the same to the other midterm exams. It's open book, open notes. You can bring all the materials to the class or to the exam. And the exam sheet will be distributed to you on Avenue to Learn. Will be available at 9 a.m. on that day. And you can then start working on the all the questions. Your answer sheet should be uploaded to Dropbox with I will generate a folder for the final exam. Name your final your submissions appropriately with the instruction in the final exam, and using even though we have 15 minutes, actual 15 minutes for you to upload your answer, but I would like you to do the uploading process as early as possible. You can upload multiple versions, and we will always create the latest one. And for your submission, you have to save them in one file and make sure that they will be ordered appropriately. If you can label the page number, that will be even better, so that if there's any potential error happens, we can always trace back how you work on the all the questions. So that's the format. Do you have any, this is very similar to what we do for the midterm exams, and hopefully don't have any complicated situations for the final. Do you have any questions for this format? Okay. Then for the final exam, the total score will be 100, and it will cover all the topics in this class, including the topics before the first and second midterms, from the first lecture to the lecture today. And there will be 5 questions. All of them would be the will need you to do some computation. You will be very similar to the your homework questions, and some questions will be quite similar to the problems you have already worked in the first 2 exams, but we may have different numbers and different assumptions. You should have sufficient time to finish all the questions in the 2.5 hours. And that's the additional information. And for the topics, this would be the information we want to, the major topic we're going to cover. First, we will have the error series. You need to know how to calculate the mean, median, variance, and standard deviation if we are provided with the a set of the observations. And then we will go through some basic measurements, including the distance measurement, what's the horizontal, how to measure the horizontal distance, how to measure distance on the slope ground, and what we can do for the correction for the temperature, for the tension, and the sag. The next basic measurement is leveling. For the leveling, we need to know the potential errors that comes from the curvature, could come from the refraction. This only applies for the long distance measurement. And for the short distance, we will usually rely on the differential leveling. You need to know what's the procedures or the steps to do the differential leveling. The angle measurement would be a little bit more complicated. There will be many different definitions about the angles, the bearing, azimuth, deflection angle, angle to the right, the interior angles. You need to know their definitions and know how to convert them from one definition to another one. And we also want to know the corrections for the declination, or what's the especially this actually applied for the angle measurement with the compass. And we also want you to know the repetition methods to increase the accuracy of the horizontal angle measurement. There will be many examples and questions in this class to tell you how to do the how to measure the angle with repetition. You have to know how to use the raw data to calculate the angle you measured and identify the accuracy of the measurement. The next thing would be the traverse. Traverse would be more complicated. I will try to combine all the fundamental measurement technologies together. For the traverse measurement, we will focus on two traverse methods. One is the deflection angle traverse. The other one is the interior angle traverse. Both of them will have the advantages and disadvantages, but these two can you should know the way to make these two equivalent to each other. If you are provided with the deflection angle traverse, you should also be able to calculate the interior angle if it's in a closed loop traverse. And you also have to know the closed traverse and the closed loop traverse and understand how to do the correction, especially the calculations of the closure errors. And if we once you have the closure errors, how you can find out the adjusted azimuths, adjusted interior angles, adjusted angle to the right, the bearing, and so on. The next thing is about the traverse computation. We have introduced the coordination method to do the computation to calculate the departure and the latitude, and how to use the departure and latitude to find out the directions of each side and so on. And with the coordination method, you need to know the compass rule to do the adjustment. We want to adjust the coordinates of each point. We want to adjust the distance of each side, and also the azimuths or the angles or the directions of the side. And for the traverse computation, you should also know how to find out the intersection between two lines, and what's the formulas you can apply to calculate the distance from one point to another line. So that's for the traverse computation. For the area of the length, that'll be relatively simpler. We have several equations for you to calculate the areas of the triangle, the areas by coordinates, and if the boundaries is irregular, we have the trapezoidal rule and the Simpson's rule to calculate the areas. You need to know how to use these equations and how to combine them to handle the complicated situation. And for route surveying, we will only focus on the two parts. One is about the horizontal curve, the other one is about the vertical curve. For the most major part will be under the horizontal curve. We need to know how what's the definitions of the curvature. Once you know the definition of curvature, and if you are provided with the information about the vertex or the point of the interest, the point of the curve and the point and tangent, and also the radius of the curve, you need to know how to lay out the curve. You can apply with the deflection angle. It can be applied with the total station system. And the compound curve is another method to lay out the horizontal curve. It's more complicated, but you don't need to understand the compound curve for more than two radius. I just want you to manage how to deal with the compound curve with two radius, and also the way for you to find out the intersection between the curve and the straight line. Regarding to the vertical curve, you just need to understand two concepts. One is the equation of the parabola, as what we introduced today. If you are provided with the slope of the two lines, the distance of the horizontal distance of the vertical curve and also the initial elevation, you can find out the equation to represent the elevation at different locations in the horizontal curve. And once you have the equation of the curve, you can find out the vertical offset from the original ground to the curve, to the vertical curve, and you can use the offset to do the construction. That's pretty much all the information you need to know for the final exam. Do you have any questions? Oh, by the way, for the tutorial session next week, we will have the TA will be there to give the review about the final exam. If you have any questions, you can also join the tutorial session to ask the questions related to your homework, related to the examples in the class. And for the lecture section next Wednesday, we will not have any class, but I will hold the I will extend the office hour. The office hour is for this class is from 12:30 to 1:30 on Wednesday. And I will make the reserve the 12:30 to 2:30 as the additional office hour on Wednesday. If you have any questions, just drop in the office hour channel in this team in the Microsoft Teams, and then I will be there for any questions. So anything you want to ask? So for the so the questions about the paper of the past year, that's it will be hard for me to provide it because the questions will be quite similar. But you can go back to review your homework exams, the 2 homework exams this year. There will be very similar format of the questions, and the questions in the final exam will be very similar to your homework questions, and also it will be simpler than most of the questions in your homework assignment. So there's also a question about the lecture next Wednesday. As I say that we will not have the lecture on Wednesday, I will reserve the lecture for the office hour, for the additional office hour, so that you can ask the questions, drop in the to just stop by the office hour channel for any questions you have. The quiz, regarding the quiz, it has been posted, and I will keep the quiz open until the midnight today, so you will have the whole afternoon and then night to work on the quiz. It should be should already been activated. Let me just double check it. I set this one to be available automatically. Okay, but anyway, you will have time until the midnight today to work on the quiz. Oh, sorry, it's not mine's not available. Okay. Yes. So I just make it available for you, so you can work until the midnight today. Okay. Any other questions? Okay. Again, as I understand the week, especially the for this class, the final week for this class, it's quite busy. Also, the final exam is very early, almost like the second day of the final week. So just we can try to utilize the last week, start from today to next Friday. Try to review all the course materials, the course notes, and the homework assignment and the questions and the solutions. And if you have any questions, just feel free to email me. I will be available at most of the time to answer your questions. Send me email, and I will reply as early as possible. Okay. If we don't have any additional questions, I will close the meeting today, and hopefully you can have time to prepare your final exam, and just feel free to contact me or the TAs for any potential questions of this class. Okay, that's good. Thank you very much for all your effort in this class, and hopefully you can all doing very well. And based on the record I see for now, most of the students in this class are doing very well. And if we keep this record for the final exam, I believe we'll have a good score for this class. Okay, good. I think that'll be all today. Thank you very much, and I will see you in the office hour next week and in the final exam session. Again, for the final exam, I will create a meeting in the exam channel, and we will do everything as what we did for the midterm exams. Okay, that's good. Thank you very much, and I will see you next week.